So if you observe the fourth problem, how we are having the limits 0 to 1 and 0 to, 1 to 2. So 0 to 1 are the limits of which variable? Here they did not mention these are the limits of x variable or y variable. But here we can follow this way, x and then y. So these are the limits of x and these are the limits of y variable. Then on interior integration, we're having x limits. So first we have to do integration with respect to x variable and we can continue like that. Okay. So same manner, if we continue with the fifth problem, okay, evaluate double integration of xy plus 2 of 2 into dy into dx. Here also on interior integration 1 and 2, exterior integration 3 to 4 is they given to us, but they did not mention 1 to 2 are the limits of which variable and 3 to 4 are the limits of which variable. In that case, according to our discussion, we can follow in this arrow mark in this way. So first we are having y and then next we are having x. So in the reverse direction, we have to go on this. So these are the limits of y variable. Y limits are on interior integration. Y is varying from 1 to 2. And x limits are on exterior integration 3 to 4. X limits are on exterior integration 3 to 4. 6.2x. Why 6.2x? What is the 6.2x? Okay, so for on interior integration, we're having y limits. So we have to do integration first with respect to y variable. Okay, that is a process. We have to do it. Okay, now if we observe the sixth problem, how it looks like. Now I'm showing only the sixth problem. Now on interior integration, what are the limits are there? 0 to x. On exterior integration, what are the limits are there? 0 to 2. Now, if we observe till now, whenever the constant limits are there on the double integration, then only we have to follow this way. Okay, then these are the limits of x variable and these are the limits of y variable. But here we should not follow this way. Why? Because what is the reason? What is the reason? Because limits on the integration are not constants. Limits on integration are not constants. So what we need to find? Double integration of y into dx into dy. And on interior integration, what are the limits? 0 to x. 0 to x. X is a constant variable. Constant? No, it is not constant. It is in functions of x variable. And exterior integration limits are 0 to 2. So on interior integration, we are having limits are 0 to x. So that means the limits are in functions of x variable. At least one limit is in functions of x. Then we have to treat these are the limits of which variable? Y variable. So double integration of y into dx into dy. Dx into dy. Limits are varying from 0 to x. And exterior integration limits are varying from 0 to 2. But on interior integration, we are having the limits are 0 to x. Again, repeating, limits are 0 to x. That means one limit is in functions of x variable. Because of that reason, we have to feel the limits are in functions of x variable. Then we can treat these are the limits of which variable? Y variable. Clear? So these are the limits of y variable. Because of that reason, we have to do integration first with respect to y variable. And these are the limits of x variable. So we have to do integration with respect to y variable. Because of that reason, what I'm doing is I'm writing instead of dx dy, I'm writing dy into dx. So first we have to do integration with respect to y variable. Integration with respect to y variable. If we do integration of y with respect to y, what we are going to get the answer is equals to integration of x equals to 0 to 2. Integration of y dy is y square by 2. What about the limits of y? Y is varying from 0 to x into dx. Now, if we apply the limits of y variable, upper limit and then lower limit, what is the upper limit? In place of x, what we have? In place of x, what we have? Sorry, in place of y, what we have? Upper limit is x. So substitute upper limit in place of y is as x. So it will become x square by 2 minus, apply the lower limit, 0 square by 2 into dx. If we do the simplification, what we are going to get is equals to integration of x square by 2 into dx. What about the limits of x variable? X is varying from 0 to 2. So 1 by 2 is constant. What is integration of x square? X cubed by 3. What about the limits of x variable? X limits are varying from 0 to 2. So 1 by 3 also bringing outside will become 1 by 6 into. Apply the upper limit in place of x, 2. So it will become 2 cube minus 0 cube. Okay. So what is the 2 cube minus 0 cube? 8 by 6. If we do the simplification, what we'll get? 4 by 3 is the answer of double integration of what is that? Y dx dy, dx into dy. The limits on interior integration are 0 to x and exterior integration are 0 to 2. I hope you understood. Clear this one? In the given integration, we are having x and y variables because we are doing integration with respect to x and with respect to y. We are doing integration with respect to x and with respect to y. Yes or no? So because of that reason, we should not have in its answer any x and y variables. Any x and y variables. If you are getting any x or y variables, then it is wrong. One of your friend mentioned as some sixth problem answer is 2x. I did not check it. I am not having the answers also with me, but still how I said it is wrong because the function that student answer contains x variable. So it is not the correct answer. Now going to the problem number 7, evaluate. Double integration of x square plus y square into dx into dy. Limits on interior integration x to root x. Limits on exterior integration are 0 to 1. Now tell me, what is our problem? This is our problem. So if we start the solution, what we can take? So this is the problem, we are getting it. But now here, what are the limits are existed in our interior integration on interior integration? What are the limits are available here? X and root x. I am saying about limits. I am not asking about limits of which variable. Okay, clear? So on interior integration, we are having the limits x and root x. The limits are in functions of x variables. Then that are the limits of which variable? Then that are the limits of which variable? Y variable. Y is equals to x to root x. And here on interior integration, we have y limits. So obviously, what is the remaining limits on exterior integration? X limits. So first we have to do on interior integration, we are having y variable limits. So we have to do integration with respect to y. So while we are doing integration with respect to y, integration of x equals to 0 to an exterior integration, we have to take as it is. But what is while we are doing integration with respect to y, what we discussed, treat x as constant. So x square into integration of 1 into dy. What is integration of 1 into dy is y plus integration of y square into dy. What is integration of y square into dy is y cube by 3. And what are the limits of y variable? Completed integration. What are the limits of y variable? X and root x. Good. Thank you. Into dx. So y integration with respect to y completed. Now we are left with the integration with respect to x variable. Before we are going to do the integration with respect to x variable, first we have to simplify this integration. So integration of x is varying from 0 to 1. X square is constant. In in place of y. What is the upper limit of y variable here? What is the upper limit of y variable? Root x. Substitute root x in place of y. So first I am substituting root x in place of y. Then what it is going to become? It's going to become as a x square into root x plus root x whole cube by 3. This is when we applied the upper limit minus of apply the lower limit. What is the lower limit of x variable we have? Lower limit of x is, lower limit of y variable is x. Lower limit of y variable is x. So now we have to substitute y is equals to x in place of y. So it will become x square into x plus x whole cube, nothing but x cube by 3 into dx. So using braces, you can. Okay. Now, doing simplification. While we are doing simplification, we are going to write as it is. Integration of x is equals to 0 to 1. Integration of x is equals to 0 to 1. And what about the first term integration? X square into x power 1 by 2. Nothing but, can we add the powers? X power 2 plus 1 by 2. Bases are same, so we can add the powers. Plus x power root x is nothing but x power 1 by 3. So what will get? X power 3 by 2 by 3 minus. If we observe here, x square into x becomes x cube minus x cube minus x cube by 3. If we want to do simplification, you can do simplification here, then you can do the integration. So now here it is equals to integral x is varying from 0 to 1, x power, what will get? 2 plus 1 by 2, nothing but 5 by 2 plus 1 by 3 into x power 3 by 2 minus 1 minus 1 by 3 minus 1 minus 1 by 3. What is LCM will get? 3 minus 3 minus 1, nothing but, what is the answer we are going to get? Minus 4 by 3 into x cube into dx. So now we can do integration with respect to x variable. What is integration of x power n formula? What is integration of x power n? X power n plus 1 by n plus 1, using that formula. So since I am writing here integration of x power n into dx is equals to x power n plus 1 by n plus 1. In place of n, whatever it may be available, we have to use the same formula. So in place of n in the first term, what we have? 5 by 2. So what is x power n formula? X power n plus 1 by n plus 1. So what we'll get? X power 5 by 2 plus 1 by 5 by 2 plus 1. What is the 5 by 2 plus 1 value? Is 7 by 2. So x power 7 by 2 by 7 by 2 plus, what about the second term? 1 by 3 into, what is x power 3 by 2 formula? Integration of x power 3 by 2 into dx. X power 3 by 2 plus 1 by 3 by 2 plus 1. What is the 3 by 2 plus 1 value? Is 5 by 2. So 1 by 3 into x power 5 by 2 by 5 by 2 minus, what about the third term? 4 by 3 into, what is integration of x power 3? X power 3 plus 1 by x 3 plus 1. 3 plus 1 is nothing but x power 4 by 4. So we can cancel these two. 4 and 4 gets cancels. So what is the last term is going to become? X power 4 by 3. But is there any cancellations are there? Okay, sorry, not completed. What about our limits? X limits are varying from 0 to 1. That things we have to mention. X is varying from 0 to 1. Here also we can mention x is varying from 0 to 1. I am not applying now. I'll apply after one more step. What is that one more step I'm going to do here? Here, 1 by 7 by 2. What is the reciprocal of 7 by 2? 2 by 7 only. So I can write this as 2 by 7 into x power 7 by 2. Okay, plus 1 by 3 into 1 by 5 by 2 is nothing but, what is the reciprocal of 5 by 2? 2 by 5. So what it can be? 2 by, already 3 is in denominator and we are getting 5. So 3 5s are 15 into x power 5 by 2 minus 1 by 3 into x power 4. Now we are going to apply the limits of upper limit of x. What is upper limit of x variable? What is upper limit of x variable? 1. In place of x, substituting 1. So what we are going to get if we substitute x is equals to 1? So simply 2 by 7 into 1 power anything is 1 only. That means 1 power 0, 1 power infinity, 1 power 7 by 2, anything is 1 only. Plus 2 by 15 into x power 5 by 2. 1 power 5 by 2 is 1 minus 1 by 3 into x power 4. 1 power 4 is nothing but 1 only, minus applying the lower limit 2 by 7 into 0 power anything is 0 plus 2 by 15 into 0 minus 1 by 3 into 0 power 4 is also nothing but 0. So if we do simplification, what we'll get? 2 by 7 plus 2 by 15 minus 1 by 3. You can do the simplification. What is LCM? It is better to use your calculator. Use your calculator and you will get a fraction. Just check using your calculator what are the thing you are getting. Therefore, double integration of, and tell me, I'll write it here. X square plus y square into, you say always fraction. Don't don't mention like a 2.5 like that. And limits on interior integration x to root x. Exterior integration limits are 0 to 1. Then, yes, good. 39 by 105. What is the 39 by 105 value? 39 by 105 is the value. If you add the numerator, all the digits, 3 plus 9 is nothing but 12. 12 is divisible by 3. 1 plus 0 plus 5, denominator, 1 plus 0 plus 5, 6. 6 is also divisible by 3. That means it is divisible by 3. So if we cancel with the 3 times, so 13 3s are 39. 3 times 35 3s are. So the answer is how much? 13 by 35 is our final answer. This is our answer for the problem number 7.
Sir,
Yes. What is LCM here? 7, 15 and 3. So if we take LCM of 7, 15 and 3, then what is the general LCM we'll get? So 3 times can be cancelled. Okay. It should not be divisible with the 7. So 15 can be divisible by 3. How many times? 3 times. Sorry, 5 times. And then 3 ones are 3. Now 7 into 5. 35. 35 3s are 105. So 105 is the LCM. Now 2 is there, numerator. But denominator 7 is there. If we divide with 7, then 3 5s are 15, 15 2s are 30. 30 plus 2 by 15 is there. Denominator 15 is there. If we cancel this, divide 105 with 15, then we'll get 7. 7 2s are 40. Minus 3 is there in the denominator, third term. So if we divide 105 with 3, then we'll get 35. Then what we'll get the numerator final fraction? 30 plus 14 is nothing but how much? 44. 44 minus 35. What is the 44 minus 35?
plus 9.
9. 9 by 105. 9 by 105. Okay. Now here 3 times it cancels. So 3 3s are okay. 3 35s are. The answer is 3 by 35 is the answer. 3 by 35 is the answer. It is not 13 by 35. Clear, students? Thank you, Mr. Then finally, the answer of our problem is 3 by 35. Now, I'm going to give you the next problem, problem number 8. Evaluate. The problem which I'm giving here, it is, we'll do again in future in 2 different ways. Anyhow, but still, we will learn here also. Limits on interior integration 0 to infinity. Limits on exterior integration also 0 to infinity. Now, if we take our integration, this integration, what it becomes, what it looks like. You learned in your intermediate, sorry, not intermediate, in your LAC subject, one concept, beta and gamma functions. I don't know how many of you can remember that, beta and gamma functions. In that beta and gamma functions, you learned a point, integration of 0 to infinity exponential of minus x square into dx equals to, what is the value? Any of you can remember it? Root pi by 2. So I am using the same formula here also. Since using this, if you want to find the solution for this problem, you must know this thing. Okay, so now here I'm going to write this is as integration of double integration of, I'm writing it is as exponential of minus x square minus y square. Then can I write it as exponential of minus x square into exponential of minus y square into dx into dy? But here on interior integration, we have limits 0 to infinity. Exterior integration, we have limits from 0 to infinity. But which limits are available on interior integration? That are x limits or y limits? How to identify that? As we discussed on the double integration, the limits they provided all are constants. 0 to infinity, all are constants. So at that case, what is the process we have to use? We have to check in this way. So what are the limits of interior integration? We are having on interior integration x limits and exterior integration y limits because of dx into dy. This is the reason. And whenever all the limits on the double integration are constants and the integrand can be written as functions of x into functions of y. If we observe, here it is, function in terms of x variable, function in terms of y variable. Now, if you observe on the double integration, all the 4 limits are constant, 0 to infinity, but the integrand is in the form of functions of x into functions of y. Though, whenever all the 4 limits are constants and the integrand can be written as functions of x into functions of y, so it belongs to case 1 type 3, case 1 method 3. So what we can do here, we can do at a time integration with respect to x variables. So I am writing integration of e power minus x square into dx. X limits are varying from 0 to infinity into what is the second factor? Integration of e power minus y square into dy. Y limits are varying from 0 to infinity. So now, if we observe using the since formula, how we got this formula? From which topic of your mathematics we learned? I am writing this one from gamma functions. You learned the proof also on this gamma function. Okay. Anyhow, you people not written the examination still now, so you can remember. If you are having the notebooks, you refer it. You are having the proof for this integral 0 to infinity e power minus x square into dx equals to root pi by 2. Okay. So now what we can write here? What is the first integration value? Integral 0 to infinity e power minus x square into dx. What is the value? Root pi by 2. Into what about the second factor value? Is also root pi by 2. Why? But the formula contains x in the rough work. But here, in place of x, if you take y also, we'll get the same. Okay. So root pi by 2 into root pi by 2. Root pi into root pi value is pi by 2 into 2 is 4. This is our answer. This is our answer. So double integration of the same problem we will do in 2 more situations. We'll see at that cases we are going to get the same answer or not. If you are unable to remember this formula, what is that? Integral 0 to infinity e power minus x square into dx value is equals to root pi by 2. Then also you can do it using our next process, next procedures. Okay. So now, is there any doubts here? You can ask. They're asking that evaluate double integration of dy into dx by 1 plus x square plus y square. Limits on interior integration 0 to root of 1 plus x square, and limits on exterior integration are 0 to 1. These are the things. Then in this case, what we have to do? What are the limits they provided on integration? What are the limits they provided on integration? All the 4 limits are constants. Yes or no? Yes or no? All the 4 limits are constants. Yes or no? No, all the 4 limits are not constants. So starting the solution, this is a given double integration. In this double integration, on interior integration, we are having the limits of 0 to root of 1 plus x square. Exterior integration limits are 0 to 1. On interior integration, limits are in functions of x. At least one limit is in functions of x, then we can treat it as in functions of x. So on interior integration, limits are in functions of x. That means that are the limits of which variable? That are the limits of which variable?
Y.
Y variable. So y is varying from 0 to root of 1 plus x square. Then what are the limits on exterior integration? 0 to 1. Then these are the limits of x variable, obviously. Okay. Now 1 by we have to do on interior integration, we have which limits? Which variable limits? Y variable limits. So first we have to do integration with respect to which variable? Y variable. So I'm writing it is as 1 plus x square plus y square, like this, into dy and then dx, and then I am writing dx. Now I'm putting brackets like this. First we are doing integration with respect to which variable? Y variable. Now you are having in your intermediate few formulas. Integration of 1 by a square plus x square into dx is equals to, what is that? What is the formula of this one?
Tan inverse 1 by a tan inverse of x by a.
Yes, 1 by a into tan inverse of x by a. But in place of x, what we have in our question? Y is there. Y is there. So now I'm using the annotations. Later I'll do it. Now here, in place of x, we are having y. Because we are doing integration with respect to x in the formula, but integration with respect to y in the problem. Okay, in place of y we are having a in place of x we are having y. Okay, what about a here? What about a here? So in place of a square we are having 1 plus x square, but we required a. How to get a? Can we write this 1 plus x square as root of 1 plus x square whole square formula? Yes or no? Whole square. Then what is a? Root of 1 plus x square. A square is 1 plus x square. Then we are getting our previous step. So like that, I'm going to write this is as integration of x is varying from 0 to 1. Integration of y is varying from 0 to root of 1 plus x square into 1 by, how we are writing this 1 plus x square as? Square root of 1 plus x square, square root of 1 plus x square whole square form plus y square into dy and then dx. If we do integration with respect to y variable, how it is like our integrand is in the form of our formula only, which I mentioned in the rough work. So what we can write here, this can be written as integration of x is varying from 0 to 1 as usual, the exterior integration, and now it is in the form of integration of 1 by a square plus y square into dy. Now what we can get, 1 by a, what is the value of a here? Root of 1 plus x square, okay, into tan inverse of x by a, but in place of x what we have? Y. So y by a, what is a? Root of 1 plus x square. Am I correct? What I am writing is correct? Is it clear to everybody? Now into dx, but we have to apply the limits of y variable. What are the limits of y variable? We have to apply the limits only for y variable. So there is no effect of y limit on this 1 by root of 1 plus x square. So that I'm putting only brackets for this. Y limits are varying from 0 to root of 1 plus x square. Now apply the upper limit. Okay, before applying the upper limit, x is varying from 0 to 1, integration of x is varying from 0 to 1, 1 by root of 1 plus x square into tan inverse of applying the upper limit. In place of y, what is the upper limit of y variable? Root of 1 plus x square. So what is the numerator is going to become? Root of 1 plus x square by root of 1 plus x square minus, apply the lower limit, tan inverse of what is the lower limit of y? 0. 0 by root of 1 plus x square. Okay, so better, it looks like 2x square. I'll rewrite it, it is x square only. Okay, so while we are doing this, what we are going to get? Integration of x is varying from 0 to 1, 1 by root of 1 plus x square into tan inverse of 1. What is the tan inverse of 1 value? Minus tan inverse of 0. 0 by anything is 0 only. What is the tan inverse of 1 value?
Pi by 4.
Pi by 4. Tan inverse of 0 value is
0.
0. So getting that values, integration of x is varying from 0 to 1. Sorry, I forgot to mention dx. Okay, first I am writing tan inverse of 1 by 2 is pi by 4 minus 0 into 1 by root of 1 plus x square into dx. Again, we are having one more point here. So pi by 4 minus 0 is nothing but pi by 4. Pi by 4 is a constant term, so we can bring it outside of the integration. We'll get pi by 4 into integration of 1 by root of 1 plus x square into dx. What about the integration of 1 by root of 1 plus x square into dx? You are having in the list of formulas or in your intermediate, integration of 1 by root of 1 plus x square into dx is equals to, anybody can remember, log of x plus root of 1 plus x square or x square plus 1. You can write like this. This is the formula. So using this formula, then what we are going to get, pi by 4 into, what is integration of root of 1 plus x square into dx value? Log of x plus root of x square plus 1 and limits to this log x, or x is varying from 0 to 1. First apply the upper limit. What we'll get? If we apply the upper limit, what we are going to get? So pi by 4 into log of 1 plus root of 1 square plus 1 is nothing but root 2. I am writing that set, minus, apply the lower limit. What we'll get? Log of 0 plus root 1 is nothing but log 1. What is the log 1 value? 0. So finally, what we'll get? Pi by 4 into log of 1 plus root 2 minus log 1 value is 0. So I am writing here, since log 1 is equals to 0. Log 1 is equals to 0. Now, what is the final answer to us? Pi by 4 into log of 1 plus root 2 is the answer of our given question.